Hey, my name is Elishai Ezra Tsur, and I am heading the Neuro and Biomorphic Engineering Lab at the Open University of Israel. This project was led by Avinoam Bitton, a graduate student for computer science, and with the support of Hadar Cohen Duwek, the lab manager. Neuromorphic or brain-inspired cameras are powerful sensors. They communicate transients in luminance as events instead of frames. Therefore, in comparison to regular frame-based cameras, they have high temporal resolution, dynamic range, and signal-to-noise ratio. In this work, we designed a hybrid imaging system, neuromorphically enhancing frame-based vision with event-driven, motion-sensitive adaptive attention. We used spatial memory and event-driven salient maps to direct a frame camera toward attentive zones. We further implemented a dynamic tolerance mechanism with which attentional zones reallocate, supporting a multiple object attention load. Finally, we enhanced our imaging system using an automatic segmentation performed in fixed time intervals on event-based reconstructed frames, allowing efficient derivation of attentive areas. This hybrid approach demonstrates an efficient coverage of a large field of view.
First, we evaluated k-means event clustering on event tensors generated for a busy road visual scene in different time intervals and various number of mean-shifted centroids. When one event cluster is considered, or when k is 1, all events are averaged, resulting in a single attentional zone, placed at the center of the generated event cluster. When k is larger, the more significant centroid is chosen and used to generate a Gaussian salient map, which will be utilized to choose the attentional area in the following frames. Then, we demonstrated the derivation of attentional map, where attention is driven towards the location of the attentional centroid in the previous frame. In the non-adaptive, attention is kept focused on the same vehicle throughout the video. When an attentional tolerance is used, attention is shifted from one vehicle to another. When a predefined polygonal area of preference is used, attention is kept within the limits of that area. In this experiment, we used neuromorphic event data generated from a visual scene containing static shapes. Events were generated as the camera slightly moved in a circular motion. Frames were reconstructed from the event tensors in fixed 33 milliseconds intervals using the FireNet neural network. For each reconstructed frame, a salient map was calculated and used to derive attentional zones. The salient map was calculated using thresholding. Adaptation was also utilized to allow the camera to switch between the zones, thus allowing the system to focus on the different shapes throughout time. We further evaluated the same method on the Mvsec dataset, which comprises a variety of scenes taken from moving vehicles. This dataset is more challenging as the camera itself moves, creating significant event streams from the surrounding. We show that in this case, a polygonal area of interest which marks the location of the road is important to allow tracking moving cars instead of the surrounding environment. To evaluate the computational resources potentially saved by the event-generated attention zones, we calculated pixel and frame-level redundancy. Frame-level redundancy considers the number of frames not captured or processed due to insufficient motion activity. We show that, as expected, frame redundancy increases with motion level. While redundancy is maximized in a static video, it is neglectable when evaluated on videos with a significant motion load. We show that searching for a significant moving patch across multiple event clusters improves frame redundancy even when only one object is moving, and that Gaussian salient maps improve it even further. When movement is apparent across many frames, pixel redundancy provides a better estimate of the required computational resources. When computed on the busy road visual scene, we show that pixel-level redundancy improves with the increasing number of centroids and when a memory-driven Gaussian salient map is used.
We would like to thank our funders and partners, and we are looking forward to seeing you all in the conference.